Hey folks, it is time to walk the walk and talk the talk of Java programming. It seems like today we're going to be dealing with the high order question, and this is the question right over here. It's exercise 3.27. I'm going to show you guys later the copy of the PDF, or rather a book we're actually using. Right now, what I'll simply do is to read the question. Suppose a right triangle is placed in a plane. I think they should have written right angle triangle. Okay, suppose a right angle triangle is placed in a plane as shown below. The right angle point is placed at 0, 0, which is the origin, by the way, and the other 2 points are placed at 200 is to 0 and 0 is to 100. Write a program that prompts the user to enter a point x and y coordinates and determines whether the point is inside the triangle. So here's the sample run. As you guys can see, this is how it looks, right? So again, it seems like it's a high order question. So what I did is I went ahead and written some portion of the final solution. However, I didn't write anything much. I just did basic things, which is to create a project. I created the project called exercise 3.27. Inside that project, I created a class called exercise 3_3_27a, which simply says you're doing it from student A's perspective. Furthermore to that, I created a scanner, as you guys can see. I also prompted my user to enter those coordinates. Okay, what else I did? Lastly, I closed my scanner. That's all, guys. There's literally nothing much I did. It's just that I want to see everything though, so let me put that on the next slide, okay, so that everyone can see what's going on the screen. Okay, it seems like it is time to proceed. As I just said, there's literally nothing I did except for retrieving user input. Okay, so it seems like I'm gonna have another variable, and it's gonna be a Boolean variable, which will simply tell us whether or not our point is within the right angle triangle. Okay, you simply go Boolean is point inside. Okay, what you will simply do at first, let's just initialize it to true, and we're gonna try to keep track of it as we go along. Okay, number one, I'll simply want to check if the x coordinate of the input is within what? Is within the rectangle. What I want to do, my approach will simply be, I'll assume I have a box here, a box of length 200 and the height. In fact, a rectangle, not a box. A rectangle of length of width 200 and height 100. And then later on, I'll take my solution one step further, and then I'll deal with the rectangle triangle. But at first, I'll simply deal with the rectangle. So now, what I want to do, I want to check. In fact, let me make this a multi-line comment. I want to check whether the x coordinate is within the rectangular box. Okay, I'll simply do that by going if I already written if. Why am I doing it for the second time? I'll simply go if x coordinate is greater than 200 or x coordinate is less than 0. What do we say? So which means that our x is round about here, so it's above 200 or greater than or less than 0. That simply tells us that our x point is not within the rectangular box, not necessarily the what you call the rectangle, which is what we're working with, right? As I just said, I'll do this in 2 steps. I'll check whether my point is within the box, a rectangular box, and then if it is, I'll then check if it is on that right angle triangle. Damn, why can I pronounce that? Anyways, okay, if this is the case, I'll simply go is point inside. I've got to update it and just go false with an E, of course. Okay, now what I want to check is now I only want to check my y coordinates, given that I should, because if we've found that the point is actually, the x coordinate of my point is actually not within my rectangular box, then there's no need for me to continue checking, because obviously that point is not on my right angle triangle. So what I want to do now is to check if my point is still within my rectangular box. Okay, if that is the case, what I've got to do is to check whether the y coordinate is within the rectangular box. Again, this doesn't check, I mean, what I've written so far doesn't necessarily check if my point is within that rectangle triangle. It checks if it is within the rectangular box. I hope everyone is clear there. Okay, as I just said, I'll do this in 2 steps. That's actually my first step, checking whether a point is within the rectangular box. Okay, so how do I go about doing that? I'll simply go if y coordinate is greater than 0, not 0, I mean 100, or y coordinate is less than 0. This is what I'm checking, folks. I'm checking if my y coordinate is greater than 100, as you can see, or if it's less than 0 right here at the bottom. In that case, I would know that I've got to update my point. My is point inside variable, I've got to say it is false, right? Okay, once I'm through with that, I mean, after this line here, after line 26, I would know whether or not my point is actually within the rectangle. not necessarily the right angle triangle, but my rectangular box. As I just told you guys, my rectangular box has a width of 200 and a height of 100. So for instance, a point right over here where I've just put my cursor, where my cursor is, that point will be considered as a point within my rectangular box, but not within my right angle triangle, right? Like P1, for instance. Okay, so what is it that I want to do my next task that I want to do right now is to determine whether a point is to the right or left of this line over here. This line, the one starting from minus the one with the points 0 is 200 and 200 is to 0. So there is a formula for that, for determining whether or not a point is to the left or right of your line, right? Given that you know your equation of the line, or perhaps you've got some points on that line, you can do a little bit of research and find that formula out yourself. But I'm simply gonna write it. It simply says, let me first start by having a variable. I'll call it determinant, which will simply determine whether a variable is to the left or right of my line. Okay, let me write this down and then I'll explain it in a moment. I'll explain it in a moment again, folks. I'll simply give a formula in a moment. Coordinates, and then I'll go 100. Okay, minus. Why am I messing up? Okay, we simply say minus and then we subtract that. From that we simply subtract x coordinate minus 0. I hope some people might follow this, even though I haven't yet explained it, but I will. Don't worry if you don't follow what's going on. You shouldn't worry. I am gonna take care of you. So again, what I was saying was, I'll simply go x coordinates minus 0. I want to multiply that by, I'll simply multiply that by 0 minus 100. Again, I did not come up with this thing on my head, you folks. This is a formula. You can check it online. Like, it simply says, let me try to put it on the comments. It simply says, you just pick a point. For instance, 200 is to 0 and 100 is to 0. And if you want to check whether, given 2 points, 200 is to 0 and 100 is to 0, given a point such as P, or such as a point with x coordinates of this and y coordinates of that, you simply pick one point. You pick the x and y coordinates of that point, or you just say, for instance, you see, suppose we have this as 0 is to 10 as point A and the 200 is to 0 and point B. You will say the y, you'll simply say the x coordinate from point B, or let me just call 0 is to 100 as 0.1 and 200 is to 0 and as 0.2. So 0 will be x1 and 100 will be x2. 200 will be 0 will be x1 from this point here. 0 is to 100. 0 will be x1 and 100 will be y1. 200 will be x2 and 0 will be y2. So my formula simply says y2 x2 minus x1, right? You multiply that by your y coordinate. I will simply put it as y. This is the y coordinate of whatever of the point that you want to determine whether or not it's on the left or right of your line. So you will simply say x2 minus x1 multiplied by y minus y1, right? Once you do that, you will then simply minus, you will then say minus x. This x corresponds to is actually the x coordinate for the point you want to determine, right? Minus x1, if I'm not mistaken. No, actually it's not x1. In fact, it is x1. It's x2. That was so stupid of me. Minus it's x minus x2 multiplied by multiplied by what's I kind of forgot this formula. It simply says it has to be y2. Oh, almost forgot y2, which is this over here. Let me check out this. Y2, exactly. It's y2 minus y1. This is the formula right here, folks. So in case you don't know it, please try to check it out. It will simply tell you whether or not a given point is to the left or right of your line, right? Okay, once I do that, I simply say if your determinant is greater than 0, is equal to, for this point inside, will simply say false. Basically that simply says that your point is to the right of your circle, to the right of your rectangle, right? Okay. Okay, what we then do, seems like we're done determining whether or not your thing is inside or not, right? So it seems like it is time to output our results now. Simply say if point is inside, then simply go system.out.print the point is in the triangle, otherwise it's not. Okay, another thing, folks, but I'm gonna talk about that immediately we finish. Immediately we're done checking out our solution. Let's pick for whatever they decided to pick. 100.5 and 25.5. 100.25 and 25.5. Are those the exact numbers? The point is in the triangle, right? Okay. Of course, you can play around with this however you like. Let's put something like something that will be outside. Something like 0 is to 101. 0 is to 101. It says the point is outside the circle. You see, using this formula here, one might argue, why did we even bother ourselves by having this variable, why did we even bother ourselves keeping track of this variable, whereas we could have forget about it and simply use this formula, the one we used, this width formula. Where is it? This over here. The question basically would be, why didn't we just use this in the first place? And if you think you do know the answer to that, please let me know down in the comments. I would really love to hear your opinion, you guys, because we could have, honestly, we could have simply used this formula over here and then get it over with this whole thing and just give out a solution. Okay, it seems like our thing works as expected. That should be it for this tutorial, you guys. See you on the next one. I'm not quite sure, honestly speaking, whether I'm gonna give out another solution on this exercise. That will depend. That should be it for this tutorial, you guys. Please give me a thumbs up, a thumbs down, whatever that you think of this exercise. See you guys on the next tutorial. Cheers, I'm gone.